We're going to start our new unit on climate. Can you tell me what the difference is between climate and weather? What would be your best educated guess? Let's talk about it. Climate and weather. Climate is the average year after year conditions of temperature and precipitation in a region. So, for instance, our climate in the Bay Area is pretty modest. We have foggy, relatively warm summers and rainy winters. Weather is more the day-to-day conditions of the Earth's atmosphere at a particular place and time. So what is the weather like today in Mill Valley or wherever you live? So climate is long-term, weather is short-term. The similarities in how they are measured are temperature, wind speed, humidity. Humidity is how much water is in the air, cloudiness, precipitation, rain, sleet, snow, etc. So they can be measured similarly, but climate is long-term, weather is short-term. So what things actually impact climate? What can determine a different climate for a different area? Well, it's something that is known as LABTOP V. Latitude, altitude, proximity or closeness to water, topography, ocean currents, prevailing winds, and vegetation. And we're going to talk about all of these. What causes summer to be warmer than winter? Well, it has to do with the tilt of the Earth. So let's talk about it. It has to also do with where New York is located. Okay, so because Earth is tilted on its axis, and its axis you can think of like a rod going right through the center of the Earth, and the Earth is tilted on that axis, the sun's rays strike the Earth at different angles. So steeper angles in summer mean more heat, and shallow angles in winter mean less heat. Why? Well, when the northern part of the Earth is facing the sun, the Earth's rays have less atmosphere to travel through before striking the surface of the sun. So there's less heat that is lost or absorbed by the atmosphere before it reaches the surface of the Earth. When the northern part of the Earth is tilted away from the sun's rays have to travel through more atmosphere before reaching the surface, and more of the heat is absorbed in the atmosphere. So different parts of the Earth are receiving different amounts of sunlight, which can be transferred into heat. It's what we feel as heat. The sun's energy is what we feel as heat. Seasonal changes occur because of the Earth's relative position to the sun. So is the part of the Earth that we're on tilted towards the sun or tilted away from the sun? And that's part of what causes our seasons. And you can see it here in this image. So we know that the sun is the center of our galaxy, of our solar system, and we know that the sun is the center of our solar system, and all the planets orbit around the sun. Well, our Earth is tilted on this axis, and when it's winter, the northern part is tilted further away than in summer when the northern part is tilted closer towards the sun. So during summer, there's less atmosphere that the sun's energy has to travel through before it strikes the Earth than in winter. And this is often why spring and autumn kind of tend to feel the same. The precipitation can be the same, the temperature can be relatively the same. The difference is that one is transitioning into summer and the other is transitioning into winter. So latitude plays an important role in climate and weather. Where you are on the Earth determines how much of the sun's energy is actually reaching where you are. So the tropics receive the most solar radiation because the sun's rays strike it at almost right angles. So there's very little atmosphere that the sun's energy has to travel through before striking the surface of the planet. So in the tropics around the equator, the temperatures are warm all year round. The temperate zones have moderate climate with colder winters and summers. So where we live, where we actually have weather, we have seasons, unlike at the equator. We have very distinct seasons. We have winters that can be so cold it actually snows, so the precipitation is freezing, and summers that can be sweltering hot. And that's all because of where we are on the Earth's surface. And the polar zones receive the least amount of solar radiation because the sun's rays strike at very low angles. The sun's energy is traveling through a lot of atmosphere, being absorbed by a lot of atmosphere before it reaches the surface. So temperatures in the poles are mostly cold. And you can actually see that here in this image. So you can see that the red are the warmer areas and the green are the cooler areas, with blue being the coldest. Altitude is also important though. This is why in California, although California has a relative climate, we have mountains that have snow, and then we have the Bay Area that rarely ever receives snow. Altitude is the height above a reference point such as sea level. So on average, temperature drops by 6.5 degrees Celsius for every 1,000 meters in altitude. So the higher the altitude, the lower the temperature on average. And we'll talk more about that in a later lecture. So altitude also impacts climate. Why does altitude impact climate? Well, think about how the Earth is heated and think about air pressure. So the radiated heat from Earth escapes because there are fewer air molecules to trap the heat in the atmosphere. So at higher altitudes, there are fewer air molecules that are bouncing off of each other. There's less kinetic energy. And because there is less air molecules, there's less molecules that are able to trap in the heat from the sun. So there's actually less pressure. Because there are fewer molecules, there is less pressure. So the higher the altitude, the lower the temperature. This is the sun's heat, and you can see 100% of it coming in. About half of that is actually absorbed by the Earth and then radiated back out to space. However, some of it is reflected by the atmosphere, by clouds, or by the Earth's surface itself. Alright, proximity to water also affects climate because land gains and loses heat much easier than water does. So areas that are closer to large bodies of water, like the Bay Area, have a constant or consistent yearly temperature range. That's why our climate is so mild here, and we don't have really, really cold winters and really, really hot summers, because we're so close to large bodies of water, both the bay and the ocean. So areas that are removed from water have a variable yearly temperature ranges, especially in the middle of the United States because they're so far from water. Okay, let's talk about fog, because fog is very unique to the Bay Area and it definitely affects our lives. Fog is produced when air is supersaturated with water vapor. So when air has a lot of water vapor in it, the water vapor precipitates into small droplets of condensation that we call fog. Advection fog occurs most frequently around the ocean because the salt increases humidity, and condensation can form at a much lower humidity level around salt. Radiation fog usually occurs after dark when the Earth radiates heat upwards, so all of the heat that the Earth absorbed during the day is still radiated upwards, and the moisture that is in the air condenses to form fog. As the heat rises, it cools, causes saturation conditions, and thus causes fog. So this is a very basic overview of fog. Let's talk about fog in relation to the Bay Area, because fog forms in many different areas for many different reasons. So why does fog move in and out of the Bay Area during the summer? If you'll notice during our summers, we actually have cycles. here in the Bay Area. We'll have 3 or 4 days where it's all fogged in, and then we have 3 or 4 days where the sun comes out and it's warm and it's gorgeous. Why? That cycle will happen all summer long. Why? Well, cold always flows to hot. That's one of the laws of thermodynamics. Cold always flows to hot. Ground is heated easier than water is, and heat pulls cool air in because cool always flows to hot. Out in the Pacific Ocean, just off the coast of San Francisco, there is an icy strip of water because there is a current that comes down from Alaska, and that brings with it cold water. As the wind rushes over that icy strip of water, and the wind is rushing towards the land, as the wind is rushing towards the land over that icy strip of water, the air cools and it condenses and it becomes fog. And that fog is then blown in over the Bay Area. And if you'll notice out to the east of San Francisco and Marin, we have hills. And that fog basically gets trapped as it gets pushed up against those hills. On the other side of those hills is the Central Valley of California. The Central Valley of California can get very, very hot during the summer. As the Central Valley begins to heat up, it begins to pull in some of that cool air that is created from the fog. As the cool air is sucked in over the Central Valley, the hot air rises because hot air is denser. So the hot air rises and it leaves all this room for the cool air to be sucked into the Central Valley and out of the Bay Area. And as that cool air is sucked into the Central Valley, the Bay Area then begins to heat up because we no longer have fog. So as the Bay Area heats up, it eventually becomes so warm that it sucks in cool air from the Pacific Ocean again, and that warm air that formed over 3 or 4 days begins to rise because warm air is lighter than cool air. As the Bay Area begins to cool down because of the fog, the Central Valley begins to start to heat up again. And it's a continuous cycle that happens all summer. Topography also affects climate. Climates differ on either side of a mountain. As air rises over a mountain, it cools, and as it cools, that air condenses and releases moisture in the form of rain. This side of the mountain is called the windward side of the mountain because the wind is rushing towards it. As the now dry air moves over the mountain, the air is now dry because it dropped all the rain. It descends and warms, usually producing a more arid side, more arid areas. So on a mountain, you'll often see one side that is very lush because it gets all the rain, and the other side tends to be very arid because it lives in what's called a rain shadow. And that rain shadow is usually called the leeward side or the leeward side of the mountain, because it's the side that the air is not rushing towards. And here's an image of that actually happening. So we have the air becoming moist because of evaporation, and wind blows that moisture towards the mountain. The air sort of gets caught at the high elevation of the mountain, causing the air to have to rise, and as it rises it begins to cool, and then the air drops all of the moisture as rain on this side of the mountain. This is the windward side of the mountain, so it creates a much more arid topography on this side of the mountain, known as the leeward side. Ocean currents also greatly affect climate. Ocean currents can warm or cool the air, just as the current that comes down from Alaska cools the Pacific Ocean off of the coast of California, northern California. Ocean currents can be considerably warmer or colder than normal air temperatures because of where they originate. Currents that come from low latitudes move warm water to areas of high latitudes. So one example of this is the Gulf Stream, which runs up the east coast of the United States. And then currents coming from higher latitudes help to moderate warmer temperatures. So our current coming down from Alaska helps to moderate our climate. And this is just a map that's showing all of the different currents. And you can see the ones in blue are the colder currents, and the ones in red are the warmer currents. And this current cycle right here, this is actually when this reverses, that is what can be responsible for what we know as El Niños. El Niños can be where some areas receive excessively dry conditions when they would normally be very wet, and areas that would normally be very wet become very dry. Winds affect climate. There are 3 wind systems in each hemisphere, and those wind systems are the polar easterlies, the prevailing westerlies, and then the trade winds. And they all have distinct areas of origin, and the volume and speed of air masses impacts climate. So how fast are those winds moving, and how much air is actually being pushed by them. We live in what are known as the horse latitudes, and the horse latitudes experience prevailing westerlies. And you can see them here. These are the prevailing winds. And we live here at about 30 degrees. These are called the horse latitudes, and what we experience are the westerlies, as you see here. Okay, ocean currents and prevailing winds, huge part of climate. So the key idea is that ocean currents are caused by winds. So winds are blowing over the surface of the ocean, and they are creating these convection currents. And the convection currents are what are helping to circulate warm and cold water. And these winds are actually caused by an uneven heating of the Earth's surface. So our sun is heating up the Earth's surface, and then that heat radiates back up into the atmosphere. And that cycling of heat is what we feel as wind. And as that wind rushes over the surface of the ocean, it actually creates ocean currents. And both of these, both ocean currents and prevailing winds, are hugely, both ocean currents and prevailing winds greatly impact our climate. Vegetation also affects climate. So vegetation can impact both temperature and precipitation patterns in an area because plants have an impact on moisture through the process of transpiration, which is the release of water vapor via stomata. Stomata are basically like pores on leaves. So plants are actually releasing moisture into the atmosphere, and that release of moisture changes the climate, because it can change temperature. So you can see a lot of vegetation in this image. Do you see Waldo? There's Waldo! Okay, that's our introduction to climate. It's a lot of information, I know. We're going to be breaking it down as we go through this unit.